Now, when we do the centrifugal pump engineering, as I told you, the definition of key terms is very important. Now, I would like to know, those who are here, are you familiar with the term BEP? So many of you know what is the BEP. So BEP, best efficiency point, this is the correct answer. Now, what is the use of it? Okay, so once you know the terminology, you will be knowing the importance of the best efficiency point also. Okay, next question is, what is MAWP? So many of you know the terminology. It is a maximum allowable working pressure. So it is good to know that you guys are familiar with the basic terms as per the code and standard. Now, what is the importance of those key terms? Why we should know? Now, for the sake of simplification, I have just considered here the two key terms. One is the rated operating point, and second is the normal operating point. Now, what it says, the point at which vendor certifies the pump performance is within the tolerance as per code and standard. So, vendor is giving the performance guarantee at this particular point, which is a rated operating point. Whereas the normal operating point, it is the pump at which pump is expected to operate under normal process condition. Now, these 2 points are mentioned in the mechanical data sheet as a rated flow and the normal flow. Now, when we know the difference between these 2 points, one is the rated condition, other is the normal condition. So rated condition here, as per the definition, it is the guarantee point by the vendor, whereas the normal point is at which the pump is expected to operate most of the time. So what is the difference here? Now, if you don't know the definition of these two terms, okay, there is a possibility that you may miss out, and you can ask vendor to give the guarantee at the normal operating point. Because why you are saying? Because you are saying that pump is most of the time it is expected to operate at this condition, then why should have the guarantee at the rated operating point? So if you are not familiar with the definition and the importance of the terms, okay, as per the code and standard, then you may land up into a problem, because once the testing is done, or once the specification you have mentioned that guarantee point should be this, but during testing the client may reject the pump because vendor is giving the guarantee at the normal operating point. Because why it has happened? Because by mistake there was a misunderstanding of the term, and you asked vendor to give the guarantee at the normal operating point, whereas as per the code and standard, rated operating point is to be guarantee point. So that's why the definition and the importance of the terms should be very much, it should be clear to everyone. Now we come to the detail engineering activities. As I told you, in case of the EPC industry, we don't directly jump to the detail engineering. Before this, there are the concept study and the feed also, which is called the front end engineering and design. But here in this case, we'll just have a focus on the first detail engineering activities. Now, whenever you are buying an equipment, so basically what we are doing, we are buying an equipment on behalf of end user or customer. So when you have to buy an equipment, what activities you are performing? So first thing is you are preparing an inquiry requisition, which is called the request for quotation. Once you prepare this inquiry requisition, this inquiry will be floated into the market, and you will get the bids from the equipment vendor. Once the bid is received, what you will be doing? You will review the bids. You will raise certain technical queries, because the you will find that bid is never complete or it is technically correct, because many times it happens that vendors are giving their standard documentation, and so it is our responsibility as a rotary equipment engineer to check the vendor offer in respect to the inquiry requisition. So during the inquiry requisition, basically the documents which you prepare, it is a mechanical data sheet and specification. So based on that, you review the vendor offer and you prepare a technical bid evaluation. So basically, you are doing the comparative assessment to know which vendor is the best. Once the bid evaluation is done and you have finalized which vendor is technically acceptable, based on that, you will prepare the purchase order. So purchase order is nothing but the request for quotation. You had prepared the inquiry requisition. So this document will be updated to issue as a purchase order. based on the technical evaluation you had done. Suppose during the technical bid evaluation, vendor has denied to comply to technical specification requirement, and you as a rotary equipment engineer has agreed for that deviation. So that deviation should be in a proper way, it should be reflected in the purchase order so that we know, vendor also know what is agreed and what he has to follow. And once the purchase order is issued to the equipment vendor, then vendor will start submitting the vendor data, which is called the engineering of the centrifugal pump. And based on the vendor data review, you will finalize. And once all the drawings and data sheets are approved, it is approved for construction, then the construction at the site will start so that you don't mess up the construction activity on site. So before that, all the major parameters and the design aspects should be approved from your end as a rotary equipment engineer. Now, next is the salient features of engineering. Why we are doing the engineering? Why don't we straight away place an order to the vendor? Okay, you give us the centrifugal pump for the given flow and head. For example, if I say 1000 meter cube per hour flow rate and 100-meter head, no need to give any specification. Is it possible in case of the engineering? It is not possible because every client has their own specification requirement. So what we have to do, we have to prepare the inquiry specification and give it to the vendors, and those and compliance to those requirements has to be part of the engineering activity. So what you will be doing as the engineering, the basic thing that the equipment supplier who has submitted the offer, that should be verified for the given parameters. So flow rate, pressure, temperature, specific gravity, viscosity, and the type of liquid. Whether the offered equipment is suitable for the given parameters, which is called the process parameter. Second thing comes the energy efficient normal operation. When we say this, because in case of the rotary equipment, whether it's a centrifugal pump or the compressor, now in case of the centrifugal pump, normal operation, it should be energy efficient. Now everywhere we are talking about the energy saving. So energy saving means what? If the design is efficient and the operation is efficient, then only it is the energy saving. So energy efficient normal operation, it is always the requirement for the engineering activity. Now when you are selecting the equipment as per the process parameter or the plant requirement, the throughput of the plant or the output of the plant, it is never going to be remain same. It will vary to some extent. So what we are saying that even at the part load operation, for example, if I say the full load operation of the pump is 1000 meter cube per hour flow rate. Now, if the plant throughput is reduced and the plant has to operate where the pump is delivering the 700 meter cube per hour flow rate. So even when the pump is operating at the 700 meter cube per hour flow rate, the operation has to be efficient. So that's why it is a efficient part load operation. Then material selection for the operating fluid. So material has to be compatible with the operating fluid. If it is a corrosive, non-corrosive, if it is a toxic, flammable. Then mechanical safe design. Now these centrifugal pumps, these are operated at a very high pressure also. So from that safety point of view, we need to make sure that it is the equipment supplied to the end user, it is a mechanical safe design. Obviously, when we are doing the engineering, the one more criteria, it is the lesser footprint or the overall dimension. So if suppose there are the three offers you receive, so obviously the one vendor who is meeting all the requirements and it requires a lesser footprint on the site. So obviously it is a saving of the land. So that vendor may get a preference over the other two vendors because the design is compact. So that's why the overall dimensions are small. So once the overall dimensions are small, obviously from the civil point of view also, the uh, uh, land excavation or the civil foundation, it will be smaller. So from that perspective, we always prefer to have the overall dimensions to be under control. So these are the basic parameters which we take care during the engineering activities.